My name is Siti Nur Akila binti Muhammad Azhar.
My name is Nofatina Jo Ali and we are supervised by Madam Nohaida binti Hanafi.
My name is Nur Izzati bin Ismail. Abstract. For the introduction, time series data is a collection that traces the evolution of the subject through time. Problem statement. Handling time series data in the form of multivariate data, which may cause it not perform well in producing results. Next, objective. To generate the association rules from frequent item set for better visualization of the time series data. And to generate interesting pattern from time series data. Methodology. By applying method association rules. Next, result. By using a priori and eclat, the best combination minimum support and confidence threshold is 1% and 80%, and both algorithms dominate in generating pattern in time series data. As conclusion, using association rule mining, this study was able to evaluate, recognize, and display the pattern of the time series data structure.
In introduction section, this project uses time series data. Time series data is an organized collection of data obtained by iterative measurement over time. It has several structures which are univariate considered for one variable, bivariate considered for two variables, and multivariate considered for more than two variables. The existence of multivariate time series make the measurement works harder, and even the visualization tools available do not quantify properly. To handle the multivariate time series, the pattern recognition is applied to deal with it in order to discover the pattern and bring out the knowledge. To generate the pattern recognition, frequent item set must be generated first. One of the techniques to generate frequent item set is association rule, as its goal is to find frequent item set and compute rules from the dataset. Association rule is a tool for finding the secret sign in the dataset, and hence called relationship analysis to find the connection between two and more objects. There are some algorithms can be used in association rules, but this project uses a priori and eclat algorithm.
Problem statement. The data represented by the real-world phenomena is way more complex and impossible to be analyzed manually. One of it is multivariate time series data, where it considers the presence of multiple variables in each time steps and make analysis work tougher. Visualization techniques available always do not represent the pattern for time series. Therefore, the objective of the project are to generate frequent item sets from time series data structures and to generate association rules or patterns from the frequent item sets in objective 1. And lastly, to compare and discuss the interesting patterns for time series data structures. The significance of the project to identify data mining techniques which provide better visualizations and data analysis for multivariate time series data. Benefits of the projects to extract knowledge from time series data for decision making or analysis. Secondly, decide which of the best methods when dealing with the particular time series data based on what the output needed.
For scope and limitation, the scope of this study is focused on multivariate time series data of receiving report procedures such as if log and R, IED will be used in the implementation of this study. For limitation, in this study is missing value of data from dataset of incident management process may affect the computational of frequent item set and association rules in pattern recognition. And data information of nominal data is not provided in detail, which make it difficult to understand the specific meaning of each nominal. Next topic is evaluation of available literature of our chosen topic, analyzing pattern in time series data structure using data mining, which helped in our research and development. Our focus on LRR, data mining, time series pattern recognition. Okay, let me explain further. Data mining is a process of study and analysis of massive number of the data to discover meaning, pattern, or knowledge. But before we get into that meaningful data, the data is need to go through some phases from selection, pre-processing, transformation, and lastly, the pattern that we get is our data mining. From here, association rule technique gonna be used in our research to get meaningful knowledge.
Association rule is used to find a secret thread in data set. This technique was proposed by Agrawal in 1993. To generate the rules, this project used a priori and equivalent class transformation known as eclat algorithm. A priori algorithm was proposed by Agrawal and Srikanth in 1994, where a priori algorithm is the most simple and easy to understand. It uses horizontal format as figured below, and it scans the original dataset for searching on the frequent item sets. Meanwhile, eclat algorithm was proposed by Zaki in 2000, where eclat algorithm is one of the most famous algorithm because it uses vertical data format as figured below. Thus, it scans currently the generated dataset. This table shows some research papers that had been done in the application of pattern recognition in time series. It can be seen that various techniques can be implemented to get the ideal result that depends on the issue involved.
Methodology. There are 4 phases involved which start at data acquisition, data preprocessing, pattern recognition, and ended at comparative analysis. Phase 1. Data acquisitions. The data entitled Incident Management Process Enriched Event Log Datasets was obtained from UCI Machine Learning Repository. There are about 1000 instances and 36 attributes in the datasets. Phase 2. Data preprocessing. The data was cleansed by removing missing values and it is then undergo data reduction by attribute subset selections. The remaining attributes and instances is 31 and 53,000 respectively. Then the data was transformed by factoring it to store it as level and categories.
Phase 3, pattern recognition. To recognize pattern in time series data, association rule will be used. There are two tests usually used in association rule mining. First, support, second, confidence. So let X and Y be represented by two different items. Support is the percentage of record keeping X and Y combination to the total number of record in database. Confidence is the percentage of the number of transactions containing the combination of X and Y to the total number of record containing X. Two-step approach in association rule mining will be implemented in a priori and eclat algorithm. The first step is frequent item set generation, which generate all item set who support more than or equal minimum support threshold. Second step is association rule generation, which is generated based on minimum confidence threshold and X approach Y, where X and Y item set and their interaction is null, as example shown in slide.
One of the algorithms used in association rule technique is a priori algorithm. The figure shows the flow chart of a priori algorithm. In a priori algorithm, there are two basic steps in generating frequent item sets, which are priori and join. Priori is filtered from the current candidate item set whose subset is not frequent in previous steps by using minimum support threshold as its parameter, and create used frequent k item sets where k is 1, 2, 3, and more. While join is self-join with previous frequent item set and create new candidate items. These are the steps of generating the frequent item set. Thus, for association rules generation, two-step approach are used in a priori algorithm.
Next is eclat algorithms. The following figure shows the flowcharts of the algorithms. In eclat algorithms, there are 4 steps involved in the frequent item sets generation. Step 1. Transform the horizontal data into vertical data by scanning the database once. Then, get the transaction ID list for each item and apply prune. The frequent k item set can be used to construct the candidate ck plus 1 item sets. The process repeats with the k increment by 1 each time until no candidate item sets can be found. The association rules generation in eclat uses the same approach as a priori algorithms.
After applying the time series of the data to mine frequent item set and generate association rule, comparative analysis will be conducted for both results generated by a priori and eclat algorithm. This analysis will be compare best combination of the minimum support threshold and minimum confidence. Second, interesting pattern based on its redundancy and performance, which is number of rules, time taken, and memory use.
To determine the frequent item set, 2%, 1%, and 0.9% minimum support threshold will use to generate association rule, followed with a constant minimum confidence at 80%. The combination between the number of rules and the frequent item set for each algorithm is a measurement to determine the proper result for the best minimum support value. As result shown, the number of rules is increased when the number support threshold is getting lower. It's also displayed that the frequent item set and the number of rules generated by eclat is greater than a priori algorithm. Thus, the best minimum support threshold was owned by 1%. Therefore, the number of rules and frequent item set generated was suitable for visualization because the number of rules obtained was not too small and not too huge, which aligned with the frequent item set. Based on scalable for both algorithms, the array sheets presents rule with high leaf value. Huge leaf value was plotted at high confidence and low support. The increase of support value has reduced the leaves. Therefore, both algorithm has high complement and relation even though the rules generated being infrequent.
Moving on, interesting patterns. Patterns or rules generated by a priori and eclat were compared and discussed by analyzing the presence of timestamps on the left-hand side and the right-hand side of the rules. The rules were generated by using the best combination thresholds. Interestingly, for the selected timestamps on the left-hand side, all of the patterns that generated by a priori were also generated by eclat. It can be seen from the table that the number of redundant rules generated are the same as a priori, but there are no redundant rules between them, indicates that there are patterns that eclat produced but not a priori. As for the timestamps on the right-hand side, there are no redundant rules between them where it indicates that both algorithms produces all of the same rules. For a better picture, patterns produced by both algorithms with open-end date of 31st May 2016 were used and listed out. It can be seen in the table that eclat produces patterns that a priori did not. In other words, eclat found information that a priori did not, which are the condition of incidence logs at that date. The conditions are the incident log is active, impact and urgency is medium, and the priority of the incident log is at moderate. In the same manner as the left-hand side, close at date with the date 24th March 2016 were used. It can be seen in the table that the patterns generated by a priori and eclat are the same for that date. Overall, the interesting patterns found between both algorithms is that eclat able to come out with the patterns that a priori did not, and both algorithms are dominant in providing the same patterns for time series data structure.
To evaluate performance of a priori and eclat algorithm, the comparative analysis was conducted. There are 3 components to compare of performance. First, number of rules, second, memory use, and lastly, time use. 2 timestamps that were selected, which is attribute open added on left-hand side and close added on right-hand side. As shown in table, the number of rules for the left-hand side generate more rules than the right-hand side. The result eclat and a priori algorithm quite similar. Next, the time used to finish the process using the eclat algorithm is shorter than a priori algorithm, even though right-hand side for the both algorithm process similar result for the number of rules. Different with the left-hand side, the number of rules generated for the eclat is smaller than a priori, but memory used for both algorithms are the same, which is on left-hand side.
For the conclusion section, the frequent items has been generated by using the absolute method, where it shows top 5 frequent items. The comparison between the frequent item sets and the number of rows generated has identified that 1% of minimum support threshold is the best threshold combination. By using 0.01 support, on the left-hand side of the rules for both algorithms shows that there are no rules that are duplicated and the non-redundant rules that are created using a flat is rather than a priori algorithm. On the right-hand side of the rules, there are only redundant rules between them. Both algorithms are dominant in creating association rules and providing the same rules for the same time series data format. For the performance, the number of rows generated on the left-hand side and the right-hand side, Eclat uses shorter time than a priori for both sides. Nevertheless, Eclat produces more rows than a priori on the left-hand side, while on the right-hand side, the same number of rows generated for both algorithms. The memory used for generating rules whose presence of time series on the left-hand side is greater than on the right-hand side. This project is able to analyze, recognize, and visualize the pattern of time series data structure using association rules mining. Both algorithms were able to achieve their objectives in pattern recognition. For the future study, this project recommends to explore how FP growth would visualize the hidden pattern with the use of multivariate time series data in comparison to a priori algorithm, since both algorithms use horizontal data formats to generate the association rules. Comparative analysis in terms of time use, memories, and frequent items also can be conducted to analyze their performance.